For this unit, we will limit our situations to when acceleration is constant, or we could call that uniform acceleration. We will not deal with an acceleration that is not uniform. So if you look at my motion map that I have here, we can see the velocity vectors in the blue where it is speeding up. And then the acceleration vectors, notice they are all the same length. It is a constant acceleration, meaning that it is speeding up by the same increments each second. So we will only deal with a constant or a uniform acceleration. We will show you what one looks like if it is not uniform on a graph, but we will not be dealing with any problems with that. So we have looked at a graph to show us when acceleration is occurring on a position versus time graph. If you look at this, we know the position time graph, if it has a slope that is changing, the object is accelerating. So to figure out what that acceleration is, we need to first figure out what the velocity and how it is changing. So if we draw the tangent lines, and the tangent lines are, you choose one point, so I choose a point, and then I draw a line just touching that point. And then I would calculate the slope of just that line. So you can see that these lines are getting steeper as I progress in time. So that means that this object is speeding up. So if we were to calculate the slope of any one of these points, the slope at that point is the instantaneous velocity. So we can see from those tangent lines, the slope is getting greater, therefore this object is speeding up. So those would be the instantaneous velocities at that point in time. Now we'll look at transferring this information from the position time graph to a velocity time graph. To do that, we would figure out the instantaneous velocities at a point in time, and then we would graph those on a velocity versus time graph. So you can see all of my tangent lines here. I've calculated the slope, and then I put that value on the velocity versus time graph. So this would show us, yes, the velocity is increasing for this time frame. So that would be an example of how to take the information from a position time graph and produce a velocity time graph. This is a position time graph that is on worksheet 4. If you look at it, you can see that the object is moving away from the origin, back towards the origin, behind the origin, and then back towards it again. Now, if we want to answer questions about this, about its speed or its velocity, we would be looking at a tangent line drawn at that point. So if you looked between A and B, you could see that the slope is decreasing, so it must be slowing down. So you need to just kind of look at the slope and compare how it is changing. Also, on this worksheet, we can also figure out the displacement. And to figure out displacement, it is the area under a velocity versus time graph. So if we had a velocity versus time graph, for an example, and let's say the object was increasing it, this area underneath that time, that is the displacement. So that would be how we can calculate displacement. Now, you might have to watch out. You might have a velocity versus time graph that may look like this. Just draw this one. And the displacement is still this area. But you would have to recognize that you would have a rectangle here, and then you would have a triangle. So you'd have to take the rectangle plus the area of the triangle to get what the displacement is. So you just have to recognize you might have to split up the area if it isn't a rectangle or a triangle. I mean, if you knew how to do the area of a trapezoid, you could also use that equation too, but if you don't, I think everybody should be familiar with the area of a rectangle and a triangle. Also, on this worksheet, you are going to have to calculate instantaneous velocities. You can do that two ways. You can either do the tangent line, which we've talked about previous, or you could do the secant line, and the instantaneous velocity needs to be at the midpoint of that secant line. So if they were asking you to figure out the velocity at 5 seconds, you would have to draw a secant line between 6 and 4, because between time of 6 and 4, 5 seconds would be the midpoint, or you could go 7 and 3. It's up to you. So that should help you do worksheet 4. If you have any questions, let me know.